Now that we have loaded the solids and created a grid, we can move into flagging. So we want to flag the domains based on the solids, and we want to flag them on our composites and also on our grid. But before I can start flagging, I need to define some domains and some domain properties that are going to be useful for us. RMSP does have tools for it. That's going to be covered on the next notebook. For now, we are going to just use Python dictionary, very basic Python dictionary for that. So let's start with the domain column. So I'm going to call it domains, and I need to specify also domain codes because I'm going to be flagging the grid with some integer codes. But I want to attach those codes to a meaningful name. So we have two grade shells, and outside the grade shell, we are going to start with the background. And that's going to be code 0. And then I'll have the low grade, which is going to be code 1, and the high grade, which is going to be code 2. So that defines the domain codes, which maps the names of the domains to the respective integer codes. Other thing that's useful for us is to define colors. So I'm going to specify domain colors, and I'm just going to use the matplotlib C0, C1, and C2 colors. And lastly, I want to also specify for each domain what solids we're going to be used. So I'm going to be calling it domain solids. And of course, we do not have a solid for the background, so remove that. The low grade is the low shell, and the high grade is the high shell. So if I run this cell, now we have all the properties we need to deal with the domain, so we can proceed with flagging. We are going to start the flagging with the definition of the domain column. So let's start with our grid. So I need to create that column, so domain column, and I will create it by assigning the background code to every block in this grid. So if I check my grid now, my grid contains domain code equals 0. So that's the background. Every block is being assigned to be 0. The function that we're going to be using for flagging is a function of the solids. So every solid is going to have this function. So let's take a look at the low shell. The function we're going to use is called contains. So the argument that this function takes is this locations, and that means that any valid spatial location within RMSP can be used within this function. So that includes the grid, that includes the composites. So if I flag my grid, the output of this function is a Boolean array with the same length of the grid, and for each block, if it's false, it means it's outside the solid. If it's true, it means that it's inside the solid. So what I can do with this Boolean array is to do a grid.lock. So this will give me access to every block inside the solid, and then I can access the domain column, and I can assign the domain code to be the domain name, the respective domain name. So now that we have prototyped the function that is going to go, the code that's going to go inside our loop, we can just copy that to the next cell. Actually, I deleted. Let's undo it. So for dom name and solid in dom solids dot items, I can have that inside. So this is my loop. Of course, now my solid is coming from this dictionary. So we are getting the domain name and the solid from that dictionary. So inside here, I have to replace low shell by the solid, and domain name is just being used to get the domain code. So if I run this loop, it's gonna flag my grid with the solid values. Of course, I want to do the same thing for my composites, so I'm gonna do actually just copy the code and change it to composites. So if I run this loop, now both my grid and composites are flagged. After flagging, we should always visualize the result of the flagging. So to do that, we are gonna create a figure. First element of the figure is gonna be our grid, and we are gonna be plotting the domain column that we just flagged. We are gonna just use the same view that we've been using so far within this notebook. Let's change the figure size, and also because I'm planning to add the solids to this figure, I want the colors to be a little bit faded for the blocks so that it helps me visualizing the traces of the solid. So far I have created a section on my block model with colored by the domains. So let's add a few more elements. So first of all, I want also to add my composites. So that's gonna be section plot draw, and we are gonna use the same view and the same column. Also, because we're plotting composites, we want to define tolerances. And then next line, I want to add my topo. We are gonna use the same view. We can use 0 tolerance and use trace color to be just black, and we need to specify the axes in both of these ones because they are the draw function. And so I have my composites, my topo, and lastly what I want to do is to add my solids. So to add my solids, I just need the loop over all the solids in the solid dictionary, and we are adding to the same plot with the same view with 0 tolerances. And then the trace color, I'm gonna use the domain color. There you go. So if we run this cell, it should generate for us a nice section plot with our block that has been flagged, the solids and the composites. Everything looks good. The flagging seemed to have worked well. One thing that you might have noticed on this cross section is that we have blocks above the topography. So far we haven't used our topography for flagging. So what we're gonna do is to use the topography wireframe to remove the blocks that are above that topography. So with open meshes like the topo, we don't have the contains function because that's part of the solids, but we do have the function called above, which also flags any valid locations in RMSB, and we have also the function below. So in this case, I want to keep every block below that surface. So let's use the function below. And what I can do now is to pass my grid to this function, and the output is again a Boolean array, which I can use to slice my grid. Because I want to just remove the blocks that are above the topography and keep everything that's below, I can slice my grid by the result of this call and just assign it back to the same object. So by running this line of code, what happens is that we're gonna be removing every block above that topography. So I can copy and paste the the plotting code in here because we want to see the same cross-section. So now you can see that the blocks above the topography have been removed. Another thing that you might notice is that on the right side here, we lost a few blocks that are probably below the topography, but because we cannot tell, because the topography ends at this point, so the code to flag below is only able to flag the blocks where the topography exists. So we end up trimming the block model to the extent of the topography. So that's why we are losing the blocks on this right side.